Joy Zeigler here, and we're going to continue with our Exam 6 review for Math 310. In this problem, we are to use the quadratic formula to solve this equation. And the first thing we need to do is put the equation in standard form, which means it should be 3x squared plus 2x minus 2 equals 0. So we get that by adding 2x and subtracting 2 to and from both sides. So we get 3x squared plus 2x minus 2 equals 0. And we want it this way so that we can easily identify A, B, and C. The quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac over 2a. It's a nice way to solve for x because all you have to do is substitute for a, b, and c. So let's go ahead and do that. We have x equals negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 2, all of that over 2 times 3. So to simplify that, we start with the radicand, and so we have negative 2 plus or minus the square root of exponents 4 minus 4 times 3 is 12 times negative 2 is negative 24. And again, be careful with negative signs. And all of that is over 6. So that's going to equal negative 2 plus or minus the square root of, well, minus a negative is plus a positive. So we can say this is the square root of 28 over 6. And the square root of 28 is 7 times 4. You can break it up because 4 is a perfect square. So we're going to use 7 times 4, which is 7 times 2 squared. And we know that the square root of 2 squared is 2. So we have negative 2 plus or minus 2 square root of, and then 7 is still left in the radical, over 6. And then we can factor out a 2 from every term in the numerator. In fact, let's go ahead and factor it out. We have 2, and then we're left with negative 1 plus or minus square root of 7 after we factor out the 2 over 2 and times 3. And we broke it up that way so that we can cancel out the 2's. So we get negative 1 plus or minus the square root of 7 over 3. And so those are the solutions for x. This problem wants you to solve this formula for a given letter. And these are actually pretty easy problems if you are comfortable with your mathematical operations. So the letter we're solving for is D, and then whenever we solve for something, we want to get it by itself on one side of the equation. So to get D by itself, first we're going to get D squared by itself, and we do that by dividing by both sides by KW. So we have S over KW equals D squared. And we're going to rewrite that with D on the left. D squared equals S over KW. And now we can use the square root property. And this becomes plus or minus when we use the square root property. And we get that D equals plus or minus the square root of S over KW, which is equal to plus or minus the square root of s over the square root of kw. But we haven't finished simplifying it yet because we have a radical in the denominator, so we need to rationalize the denominator. And so we do that by multiplying numerator and denominator by something that will get rid of the radical. And since it's a square root, that's very straightforward. We just multiply by the square root of kw over the square root of kw, and that gives us that d is plus or minus the square root of skw over kw. And that's the answer. We're going to use the square root property to solve this equation. First, we get our variable term by itself on the left side of the equation. And now we divide by the coefficient in front of our variable so that we get t squared equals 8. Now we can take the square root of both sides using plus or minus on the right side, and we find that t equals plus or minus the square root of 8, and you should memorize that the square root of 8 is 2 square root of 2 because you'll be using it a lot. So your solution set is 2 square root of 2 and negative 2 square root of 2. In this problem, it wants you to find all of the complex solutions, and that gives you the idea that we're dealing with complex numbers, and complex numbers are of the form a plus bi, where I is the imaginary number. So we have a squared term on the left. We can then take the square root of both sides right off the bat. And we see that we're taking the square root, and this is going to be plus or minus. We're taking the square root of a negative number. So on the left we have a minus 5 equals plus or minus the square root of 3, and then the square root of the negative sign becomes I. Then we add 5 to both sides, and we get a equals 5 plus or minus the square root of 3i, and we can write our solution like that, or we can write two solutions, 5 plus square root of 3i and 5 minus square root of 3i. And you'll notice that both of these solutions are in this a plus bi form. We've worked a problem like this one in class. We have Jennifer and Bill wanting to buy a rug for a room, and the room is 20 by 15 feet. When they install the rug, they want to leave an even strip of flooring uncovered around the edges of the room. And so how wide will the strip of flooring be if they buy a rug that has an area of 234 square feet? So here's a diagram, a picture of the room. The room is 20 by 15, and the carpet, the rug, is 234 square feet. And what we want to find is the distance here between the rug and the wall. And we'll call that distance W. So what can we observe about this picture? We know that the area of the rug is 234 square feet, and we want to find the width, but we don't know what the lengths of the rug or the width of the rug are, and we do know the length and width of the room. So what we could do is we could see if we know what the sides of the rug are in terms of W. So we know that the length of the rug is 20 feet minus 2 times W, because W is on the left and W is also on the right. So if you take this total length and then you subtract out W here and here, taking away this part and this part, then you get 20 minus W equals 20 minus 2W. And over on the, so this right here is 20 minus 2W. And then we're going to come out here and say the width of the rug is going to be 15, do it in red, 15 minus 2W. Because the total width is 15 feet, and then we're taking away this width and this width, which is W and W, so it's 15 minus 2W. So basically we have a rectangle. Let's just draw the rug itself. We have a rectangle that's 234 square feet, and its width is 15 minus 2W, and its length is 20 minus 2W. And now we have expressions of length, width, and area that have W in them, so we can solve for W. So our equation we're going to use, of course, is the area of a rectangle is the length times the width. So we know the area is 234 square feet, and that's going to equal 20 minus 2W times 15 minus 2W. And so now we've set up our problem, and we just have to solve it using the techniques we've already learned. Since I'm more comfortable with having my W's on the left and my numbers on the right, I'll rewrite that equation with the W's on the left. Now I'm going to use FOIL, and I get 20 times 15 minus 2 times 20 times W minus 2 times 15 times W plus 4W squared equals 234. And to clean that up a little bit, I know that 2 times 20 times W is going to be 40W, and 2 times 15 times W is going to be 30W, and so when you combine these are going to be 70W. So 20 times 15 is 300 minus 70W plus 4W squared equals 234. And let's just go ahead and rewrite that with descending power. So we put 4W squared first, minus 70W next, and plus 300 equals 234. Now to solve, we can use either the quadratic formula or completing the square. I think I'm going to use the quadratic formula, and to do that I need to rewrite this equation in standard form. So now I've rewritten the equation up at the top and cleaned up a little bit. To rewrite it in standard form, we just subtract 234 from both sides, and so we get 4W squared minus 70W plus 300 minus 234 equals 0. And 300 minus 234 is 66. So we have 4W squared minus 70W plus 66 equals 0. Okay, I like to see if I can pull out a common factor, and in here all of these numbers are divisible by 2. So let's rewrite that. After dividing everything by 2, we get 2W squared minus 35W plus 33 equals 0. That makes our numbers a little smaller and easier to deal with. Now we want to identify A, B, and C, and our formula says that W is going to be negative B plus or minus the square root of B squared minus 4AC, all of that over 2A. Okay, so let's go ahead and substitute in. W equals negative B, which is negative 35, plus or minus the square root of B squared minus 4 times 2 times 33, all of that over 2 times A, which is 2. So this is going to equal 35 plus or minus the square root of 1225 minus 4 times 66 is 264 over 4 equals 35 plus or minus the square root of 961, all of that over 4, which is 35 plus or minus 31 over 4. So that's nice. That's going to be 35 plus 31 over 4, or 35 minus 31 over 4. So that means W equals 66 over 4, or 4 over 4. And 66 over 4 is 16.5. So W is either 16.5 feet or 1 foot. Okay, so we go back to our original picture, and in the middle we have the 234 square foot rug, and it is 20 minus 2W long and 15 minus 2W wide. Now if W equals 16.5, the width of that rug would be a negative number, 15 minus 16.5. And we know that that is impossible, so we can go ahead and discard the 16.5 length, and that tells us that W equals 1 foot. So we check that out. If W is 1 foot, then the length of the rug is going to be 20 minus 2W, which is 18. And the width of the rug is going to be 15 minus 2W equals 13. So the area of the rug should equal 18 times 13. And when I put that in my calculator, I get that that is equal to 234 square feet, and that checks with what we know about that rug. So the correct answer is that the strip of floor around the rug is going to be 1 foot. In this equation, it's similar to an earlier problem where we used the quadratic equation. So we're going to rewrite it in standard form, which is 3x squared minus 11x minus 5, because we subtract 5 from both sides, equals 0. And we're going to identify A, B, and C and write out what the formula is, which is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you really need to be able to recite that in your sleep. So let's go ahead and plug a, b, and c into this, and we get x equals negative b, which is negative 11, plus or minus the square root of b squared, or negative 11 squared, minus 4 times a times c, all of that over 2a. So that's going to equal 11 plus or minus the square root of 121 minus 12 times negative 5 is positive 60 over 6. And that's going to be 11 plus or minus the square root of 181 over 6. And so now the problem becomes simplifying that radical, because 181 is not a perfect square. So we need to decide if it's a prime number or if it can be factored. And the way I would do that is go through a few of your prime numbers. You know that it's not divisible by 3 because if you add up those digits, they're not divisible by 3. And it's not even, so it's not going to be divisible by an even number. And it's not divisible by 5 because 181 doesn't end in 0 or 5. So then you can try 7, and that isn't a factor. You can try 11, and that isn't a factor. And go ahead and try 13 and 17. And that's probably good enough. So none of those work, so we can feel safe about saying that 181 is a prime number, and we can leave it in the radical just as it is. And so our solution is either 11 plus 181, or the square root of 181 over 6, or 11 minus the square root of 181 over 6. This is the last problem of the review, and again we're going to use our quadratic formula. But first we have to distribute and transform this equation into standard form so that we can do that. So we're going to distribute the 5m to get 5m squared plus 35m equals 15, and then we'll subtract 15 from both sides. 5m squared plus 35m minus 15 equals 0. And then we can divide everything by 5, or pull out the common factor of 5. So we get m squared plus 7m minus 3 equals 0. And when we divide both sides by 5, we still get m squared plus 7m minus 3 equals 0. So now we can get ready to do our quadratic equation, which says that m equals negative b plus or minus the square root of b squared minus 4ac over 2a. And a in this case is 1 because there's no coefficient in front of the m. So we have that m equals negative 7 plus or minus the square root of 7 squared, and I'll go ahead and write 49, minus 4 times a is 1, times c is negative 3, over 2 times 1. So that's going to be negative 7 plus or minus the square root of 49 plus 12 over 2, which is negative 7 plus or 9 minus the square root of 61 over 2. And since 61 is a prime number, that is our answer. M is either going to be negative 7 plus square root of 61 over 2, or m is going to be negative 7 minus square root of 61 over 2. And that is the end of the review for your last exam of the semester. So I hope you do very well. I hope you'll study, take some practice tests, use the study plan, and get very well prepared so that you can go out strong on exam 6. Good luck.